79. 79. It is type 1. Awesome. 3x squared plus x minus 4 over 2x squared minus 5x. Perfect. So, I said it, but I shouldn't have. Is this type 1? Why? Same degree over same degree. Can you identify the horizontal asymptote without doing anything? Of course, they have to be in descending order, and they are. Exactly. I'm done with that. Done. That's what I said. The first one took 15 minutes. The next one would take 3. And then from there after would be 1. Good. So let's look at the top and see if we can factor it. That's crucial. And let's look at the bottom. And the bottom is more friendly. Before I find the domain, I have to factor everything, because I can't, especially the denominator. So what will you say about the denominator? Awesome. And what is left in parentheses? Good. Before we work on the numerator, can you identify the domain for me? Anything but 5 over 2 and 0. Do I know whether these are vertical asymptotes? Not yet. I think they will be, but it all depends on the top. Because if this factor goes away, then this will be a hole in the graph. If this factor goes away, then this will be a hole in the graph. If these two factors stay, both of them will be vertical asymptotes. So now let's go back to the top. We need to factor the top. So let's take it aside. I keep promising myself not to let him pick problems, but it's okay, I'm kidding. Okay, so I need to factor this. 3 times negative 4 is negative 12, right? So the product of these two numbers is negative 12, and their sum is positive 1. Do I have two numbers whose product is negative 12 and whose sum is 1? Say it again. No, because the sum will not be 1. Very good. This is what I'm going to change the middle one into. 3x squared plus 4x minus 3x. I'm using exactly what you gave me, and minus 4. I did not do anything other than I used those numbers to create the positive x. I need 4 terms. I'm not going to go back and combine like terms. But what do I do with 4 terms always? What is it called? Factoring by grouping, of course. From the first two, what will you tell me to factor out? Good. What is left in parentheses? What will I write in parentheses before I look? Because if I look, who knows what I come up. I have to write x plus 4, and now I look. I need a sign and a factor. Oh, yes, that's why. That's why. I talk too much. Thank you. Indeed, of course, it's 3x plus 4. So that's why it's 3x. I'm sorry? Negative 1. So very good. So this is 3x plus 4. And in parentheses? Good. So this is what I write at the top. And now I'm asking myself again, are these two vertical asymptotes, one of them holding the graph, or both of them holding the graph? Both of them vertical asymptotes, because they do not go away with any factor from the top. So now I will write x equals 0 VA, x equals 5/2 VA. I would put my infinities left and right and wait till I find the sign of those infinities. I will use negative 0.1, positive 0.1. I will use 1.4 because this is 2.5, 2.4, and 2.6. 5 divided by 2 is 2.5. So a little bit to the left, 2.4, a little bit to the right, 2.6. No calculations are required, just a sign. So negative 0.1 plus 4. This will be smaller than 4. Positive. Negative 0.1 minus 1. Very good. Negative 0.1. Negative 0.1 times 2 is negative 0.2. Negative 0.2 minus 5. 3 negatives. Awesome. Very good. With 0.1, 3 times 0.1 plus 4. 0.1 minus 1. 0.1. 2 times 0.1 is 0.2. 0.2 minus 5. 2 negatives. Done. 2.4. 3 times 2.4 plus 4. 2.4 minus 1. 2.4. 2.4 times 2 is 4.8. 4.8 minus 5. 1 negative. Last one, 2.6. 2.6. 2.6. 2 times 2.6 is 5.2 minus 5. So let's see what we accomplished in a few minutes, really. We have domain, we have vertical asymptotes and behavior near vertical asymptotes. We have the horizontal and the slant, we have the end behavior. What we don't have yet is the x and y intercepts. Max, min, I have to look. Symmetry, none. Because if it has a vertical asymptote at 0 and 1 at 5/2. Okay, so when is a fraction 0? When the numerator is 0. When is this numerator 0? When x is 1. And when x is, move 4 to the other side, it becomes negative, and divide by 3. Very good. Finally, I would like to plug in 0 to find the y-intercept. But can I plug in 0? It's undefined at 0. So there is no y-intercept. That's it. So please follow my marker or my hand. From 3/2, crossing the x-axis at negative 4/3, 0, and going to negative infinity on the left-hand side of the first asymptote. One more time. From 1.5, crossing the x-axis and going towards negative infinity. On the other side of the first asymptote, coming from positive infinity, crossing at 1, 0, and going towards negative infinity on the left-hand side of the second vertical asymptote. One more time. From positive infinity, crossing the x-axis at 1, 0, and going to negative infinity on the left-hand side of this asymptote. And finally, from positive infinity, approaching 1/2. We haven't even graphed it, but the chart gave us all the information we need. So when I graph a function with asymptotes, what do I have to graph first? Good. So this function has 3 asymptotes. Oh, I should have showed you. I want to show you with the graphing calculator the previous one as well. So 0. This is an overkill because I already have this line. 5/2 is 2.5. And 3/2 is 1.5. Okay, one more time. Let's do this one more time. From approaching 3/2, we will cross at -4/3, 0, and going towards -infinity. On the other side, it's coming from positive infinity without touching the asymptote, and crossing at 1, 0, and approaching -infinity on the left-hand side of this one. On the right-hand side of this asymptote, it's coming from positive infinity going to 3/2. So I have to plot this -1 point something, so somewhere here, and I have to plot this 1, 0. That's all I need. All the information is right here. One more time. From 3/2, crossing at this point and coming down towards -infinity, getting closer and closer. This is this portion. The middle part, from positive infinity, crossing and approaching, -infinity. This is this part. From positive infinity, crossing at 1, 0, and going to -infinity on the left-hand side of this asymptote. On this side, done. From approaching positive infinity or coming from positive infinity, approaching 3/2. Good pick, Kim. I was kidding, of course. Good pick. Okay, so let's go to the graphing calculator. In y equals, with these rational functions, you must put parentheses around the top. You must put parentheses around the bottom. Lucy, you want to use my calculator?
Yes.
Does anyone else need a calculator? Okay, I don't have 2. I only have 1. Yeah, I should have another one. It may not have a battery. I think I charged it. I'm not sure. Double check. Okay, so parentheses around the numerator, please. Clear. Parentheses. What did I have? 3x squared plus x minus 4. Close the parenthesis, divided by 2x squared minus 5x, and close the parenthesis. The calculator will not put the horizontal asymptote in. What was the horizontal asymptote? 3/2, correct? The horizontal one. Okay, you have to make up another function. So 3 divided by 2. Now, I know where the action is, and I can use the standard viewing window, because I know what happens in there, right? I have the graph. There is no way the graph will look differently. So -10, 10, -10, 10 is good enough. So I'm going to go to Zoom and choose 6. Here it's coming from 1.5, crossing here at -4/3, coming down towards the vertical asymptote, coming from positive infinity, crossing at 1, 0, going towards -infinity, and coming from the positive side, or the right-hand side, so this is at 3.5, and approaching 1.5. And this is the horizontal asymptote 1.5. And there is nothing else I can teach you about type 1. This is it. And in order to show you that this function, rational function, is very useful, you're going to see a lot of them. This is an application, here's another application, here's another application of rational functions. That's why we look at them. Now, for example, here, look at the numerator and look at the denominator. Can anyone give us the horizontal asymptote? Uh, 428, page 428, problem 101. 428, problem 101. Can anyone give us the horizontal asymptote? That's it. As you see, the function gets closer and closer, closer and closer to 6.5. We're going to look at that. Okay, let's look at type 2. Type 2 is much easier than type 1. I shouldn't say much. What the difference is, this is always 0. That's the only difference. In type 2, this is 0. Why? Because the denominator is so much bigger than the numerator that at infinity, because it has a higher degree in the denominator, at infinity the function approaches 0. That's the only difference. So can anyone give us a type 2 from your book? From 21 through 88. Type 2. Higher degree in the denominator. By anything higher. It doesn't matter. Anyone? I've got one. 72. Is x minus 4 divided by x squared minus x minus 6. Is this type 1? It's not type 1 because the degree of the top and it's okay. The degree of the top and the degree of the bottom are not the same. Correct? Good. So I start by doing what immediately? Yes, I'm ready when you are. Very good. X minus 3x plus 2. Good. So now you have the domain. What is the domain? Anything but -2 and 3. Undefined underneath. Now I want to establish right away whether these will be vertical asymptotes. Yes or no?
Yes.
Yes. So x equals -2 is a VA and x equals 3 is a VA. Because I know that, what happens left and right? For sure. Yes, I don't know which type, if it's positive or negative, but I will establish that in a minute. Using numbers very close to -2, like -2.1, -1.9, and 2.9, 3.1. No calculations are needed, just sign. -2.1 minus 4. Sign. -2.1 minus 3. Sign. -2.1 plus 2. 3 negatives, please. Very good. -1.9 minus 4. Negative, right? -1.9 minus 3. Careful now, -1.9 plus 2. So the sign with 2 negatives will be awesome. Yes, always. 3 negatives will always give us negative. An odd number of negatives. 2.9. 2.9 minus 4. 2.9 minus 3. 2.9 plus 2. 2 negatives. Very good. Last one, 3.1. 3.1 minus 4. 3.1 minus 3. 3.1 plus 2. 1 negative. Because it's type 2, what is the end behavior? Always at infinities. 0. So 0, 0, y equals 0 is a horizontal asymptote. I need you to plug in 0. Here's how I plug in 0. I plugged in 0. What is the answer? 2 over 3. Very good. And finally, I want you to find the x-intercepts. A rational function is 0 when a ratio is 0 when the top is 0. So when is the top 0? At 4. Multiplicities, how many times? So that will be? Good. I'm done. So let's analyze this, see what happens, and then graph it. From approaching 0, coming down to negative infinity on the left-hand side of the first asymptote. On the right-hand side, it's coming from positive infinity. It crosses at 0 2/3, and it's going back up. I don't know where it's turning. I need a calculator for this. So it's coming from positive infinity. It does not go to negative values, 0, 2/3. Turn somehow, somewhere, maybe here, maybe not, we have to see, then goes up to positive infinity. Okay, here now. This is weird. This part is weird. Here's why. It's coming from negative infinity. It crosses at 4, 0. It's on the positive side of the y-axis. But then it has to do this. Why? Because it has to approach the asymptote. So that's why this is a little bit more complicated, this portion. From negative infinity, it's crossing at 4, 0, but it has to reach a maximum because it has to come back and approach 0 eventually. Okay? It's not possible to jump from 0 to 0, right? So it's coming from negative infinity. It has to turn, crosses, it has to turn, and then approaching eventually 0. So, did I choose that? I did. Okay, I can argue about that. Just kidding. Okay, so when I graph a function with asymptotes, what do I have to graph first? Yes. So there is one at negative 2. X equals negative 2. There is one at 3. And this is an overkill, but I'm going to write it, to graph it, just to make sure that we don't forget. Why this is an overkill? Why? Because it's right there. It's already there as the x-axis. Okay, I'm back to my chart. Nothing else matters. Ready? Here it is. This portion is very clear. From approaching 0 to approaching negative infinity on the left-hand side of the first asymptote. No problem there. 0 2/3 is a point here. Somewhere. 2/3. It's coming from positive infinity. I doubt that it turns here. I think it continues to a minimum. There are no x-intercepts there, so it cannot go to negative values, and then eventually go into positive infinity. This we have to check. This crosses at negative 4, but it has to eventually come here. That's what this says. So it's coming from negative infinity, it crosses, it must have a turn, and eventually approach infinity. You know what I mean. At infinity, approach 0. So this is what I call max-min situation, which I cannot determine without the graphing calculator. But this is definitely the graph. There are no questions there. Okay, so let's take a look. Parentheses around the top, parentheses around the denominator, and there is no need for this function to put y equals 0 because the x-axis will be there anyway. So, in parentheses, the top, x minus 4. In parentheses, x squared minus x minus 6. I know the action happens between negative 10, 10. I'm okay for now with the standard viewing window, so I just hit graph. It's coming from 0, approaching negative infinity. It's coming from positive infinity. Obviously, it does not turn here. It turns lower than, what was it, 2/3, right? Lower. This, I know it's a lie. No, it's a lie. Because it has to cross at 4. 1, 2, 3, 4. And it cannot follow the x-axis. This is not a function that is always 0. It's not possible. So I have to investigate this, but first I want to investigate this minimum. So I know the minimum is definitely between 0 and, so second and calc, I want the minimum with number 3. And from 0, yes, 0 left bound is good. And the right bound, I don't want to guess. I'm going to just make sure I pass the minimum and guess. Here it is, 1.55. I put it in the chart. So at 1.55 is 0.48. So this is the minimum. So 1.55, comma 0.48. And now I'm going to decide where it's lying to me. Okay, so all I'm interested is in this portion now. The rest is clear. So I go to the viewing window. I want the viewing window to start at 2 for x. Go, I don't know how far. I'm going to say 20 for now, with a scale of 2. Y minimum, I don't care. I'm going to say -1. I don't care for the negative part. I know where it's going. And the y maximum, I want 1. I don't know if that's what I'm looking for. With a scale of 0.25. Very clear now. It's coming from negative infinity. It crosses a -4. It reaches some sort of maximum, a tiny little maximum, and then it comes down to 0. So I want to determine that maximum. So I'm going to say second and calc. Maximum is number 4. I want at 4 as my left bound. And my right bound, I can take it and move it till I see it passes that maximum, that bump. It did. Okay, enter. Just give me the maximum. So it's 0.08. I don't know what kind of a maximum is 0.08, but that's what it is. So 6.44, comma 0.08, 0.084. Now I know absolutely everything about this function. So it's right here at 6.44, comma 0.084. Any questions? Yes, please.
I don't know if I wrote it down wrong. So what's the horizontal asymptote?
0.
0.
Yes.
So
For every type 2, because the denominator is so much stronger than the numerator, at infinity it's 0.
and so how come it cross? So is that like an open circle?
Awesome. Awesome question. A rational function can never ever cross a vertical asymptote, but it can cross a horizontal asymptote. So using the explanation, the horizontal asymptote has no meaning here. But I cannot graph a little piece here towards negative infinity and a little piece here towards positive infinity. I have to graph the entire line. But right here in the middle, it makes no sense. It doesn't mean anything. It only means that eventually the function will approach 0. Eventually the function will approach 0. In the middle, it can do anything. So what I should do, it's a very good, awesome question. Thank you. Thank you. Okay? So what I can do is just graph this little piece and this little piece. But then you're going to say, and rightfully so, what is this? Then I have to say it's the horizontal asymptote. But in here, in the middle, don't cross out anything. In here doesn't mean anything. It only says that after a while, a big while, the function will approach 0. And after a big while towards the negative side, it will approach 0. So a function can cross a horizontal asymptote, but it will never, ever cross a vertical asymptote because it's undefined there. Any questions? Any questions? Because I only have 6 minutes left, I think we should choose either type 1 or type 2 and do one more, because I need a little bit more time for type 3. You want to do another type 2?
Sure.
Okay, very good. So please choose another type 2. Anything that you would like to pick, type 2.
76.
So after we did all these 3 examples, you realize that it's not such a big deal, but it requires a lot of practice. Would you agree or not really?
Great.
I'm sorry, Tim, forgive me. You said
So I just picked 76.
you picked 76. 76 is not type 2.
No.
We are looking for a degree higher in the denominator.
Gotcha.
And by the way, 76 should not even be in that book. We cannot even do this in pre-calculus. You have to wait till calculus. That should not be there. Because we can't do anything. It has to be with a calculator. It's not type 1, it's not type 2, it's not type 3. Yes? Reese?
68.
68. Let me take a look. Awesome. Is this type 2? Yes, it is. Higher degree in the denominator. What will I do immediately? Good. I will factor the denominator. Do I know the end behavior already? What is it? Very good. Good. So then, how do I factor x squared minus x minus 2? Correct. And good. Now I know the domain. What is the domain? Not. Careful.
Negative 1.
-1 and 2. Please plug in 0 in this function. Here's how I plug in 0. Look here for a second. Please plug in 0 in this function. Very good. Is x equals -1 a VA?
Yes.
Good, because it doesn't disappear. Is x equals 2 a VA? Because it does not disappear. Perfect. We plugged in 0. Is this function ever 0? A rational function or a ratio is 0 only when? Yes. Can the top be 0? No. Good. That's it. I'm done. Other than left and right. And then I'm done. So -1.1, -0.9. As you see, these numbers are just helping me to determine the sign. I'm not going to plot this. And they have no room in the chart. Other than, and no other reason for me to look at them. Good. So -1.1. So the numerator is negative no matter what. Now the denominator. Negative 1.1 minus 2. Negative 1.1 plus 1. 1, 2, 3 negatives. Good. Negative 0.9. Negative 0.9 minus 2. But negative 0.9 plus 1.
Positive.
2 negatives. 1.9. 1.9 minus 2. 1.9 plus 1. 2 negatives. Last one. 2.1 minus 2.
Positive.
And positive and 1 negative. That's it.
Can we assume, like,
No, you cannot, because you have this one option, you have this the second option, you have this one option, and this one option. Don't assume.
so even if you do one side, you assume
You-
the other
no.
side?
No, because you also have this option. Or this option. Okay, so follow me please. From 0, approaching negative infinity. From positive infinity, crossing the y-axis at 0, 1, and going back up. Same situation, there is a turn somewhere, I don't know where. It may turn here, I don't know. There is no a negative, it does not cross the x-axis, there is no negative portion here. Positive, crossing at 0, 1, going positive again to positive infinity. Here, from negative infinity to 0. So let's graph. We have to graph what first? We have to graph the asymptotes. So there are 2 asymptotes here, 3 actually. So one at negative 1, one at 0, which is an overkill, and one at 2. So one more time. You only need the chart, all your summary, or whatever you want to summarize it as, whatever, I'm fine. Just use a summary of some sort. So this is clear from 0 to negative infinity, no questions there. This is also clear from negative infinity to 0, no questions there whatsoever. Here at 0, 1, positive infinity going back to positive infinity, I don't think it turns there. Because it will be, this is too small and this is much bigger, so for it to turn here is kind of unlikely. So this is our function f of x. I always have to write the function, so please always write the function next to the graph. Negative 2 over x squared minus x minus 2. I know it's 8:51. I don't want to hold you over, but please check and find the, if you want to stay, we can,